In the last lesson, we showed how to use invariant programming to write recursive functions that are loops that calculate with integers. But integers are rather simple data type. Usually we would like to do calculations with much more data, with many integers, for example. And so we need something called a compound data type. And one of the most basic compound data types is called the list. A list is an ordered sequence of elements, for example, integers or even other lists, with 0 or more elements in the sequence. So lists were invented in the language Lisp in the 1950s, and they are a staple of symbolic programming. So most symbolic programming languages support lists. So let me show you how lists are supported in Oz. For example, I declare L is equal to, with brackets, the list 1, 2, 3. So you notice the brackets here. And this is a list with 3 elements, the integers 1, 2, and 3. So if I do browse L, I will get here displayed on the left the list 1, 2, 3. So we can do calculations with lists. So for example, I can do M is append L, and then browse M. So this will do an append, which is concatenating the elements of the two lists. So the list M will contain the elements 1, 2, 3, 1, 2, 3 in that order. So let me feed this and show you the value of M, 1, 2, 3, 1, 2, 3. We can also talk about lists with 0 elements. This is called an empty list. In Oz, the empty list is written nil, N-I-L, in lowercase for historical reasons. Each language, symbolic language, has its own way of noting lists and empty lists. So in Oz and in some other languages, it's denoted by nil. So browse N, for example, will give nil. And if I do a calculation with this, if I do, for example, append of L and N, this will append a list of 3 elements and a list of 0 elements. So this will give simply the list L again, the list 1, 2, 3. So you see how calculations are done with lists. Lists appear to be very simple kind of data structures, but in fact there are some subtleties. Lists are actually a recursive data structure, and if you write programs with lists, you have to respect the recursive structure. So we will have to give a more precise definition of what is a list and how lists, for example, can be traversed if we want to write programs that calculate with lists. And the final point is that lists are values. We are still in the functional paradigm. And so, for example, the L and the M and the N here have been bound to list values and cannot be changed. So like integers, lists are also values.